Good evening, children.
Good evening. Good evening.
Good evening, ma'am.
Good evening, children. Good evening. I don't know how the audio settings had changed. Nobody uses my laptop, but I don't know, some of the settings, had changed, so I had to reset it. Sorry. Thank you so much for bearing with me. I'm late by 20 minutes. Okay. All right, children. So we have to continue with this. I think I'd asked you to take screenshots of these pictures and complete them in your notebook. Let's see the explanation now. If two parallel lines are intersected by a transversal, then prove that the bisectors of any pair of alternate interior angles are parallel. Okay, so what is given in this statement? What is given and what is that we have to prove? Let's understand that. If two parallel lines, okay, so two parallel lines, the two lines are parallel to each other. If two parallel lines are intersected by a transversal, so this is given to you. Two parallel lines intersected by a transversal is given to you. Then prove that the bisectors of any pair of alternate interior angles. We know that we have two pairs of alternate interior angles. We have two pairs of alternate interior angles. You can take any pair. You can take any pair. So here in this working, you can see this pair is considered. You can even take this pair. You can even take this pair. The same working. The working will be the same. Okay. All right. So given two parallel lines intersected by a transversal. So this is the pair of alternate interior angles. Now you will have to take their bisectors. So now this is the angle. So this, see, if this is the angle, its bisector will be somewhere like this. And this is the other angle. So the bisector of this angle will go like this. Because see, this is the angle. So it will go through the middle. See here, like this. This is the angle. The bisector will pass through this middle point like this. There is a construction for bisecting an angle. There's a construction. Okay, so it's not just, marking a dot and drawing a line. It's not like that. So these are the bisectors. These are the bisectors of a pair of alternate interior angles. You need to prove that these lines, that is, these bisectors are parallel to each other. You must prove that the bisectors are parallel to each other. What are we given? We are given that the lines are parallel. You must prove that the bisector lines are also parallel to each other. We are given that this line is parallel to this line. You need to prove that the bisectors of a pair of alternate interior angles are also parallel to each other because the lines are parallel. Because the two given lines are parallel to each other, we need to prove that the bisectors of a pair of interior angles are also parallel to each other. So this is what we'll have to prove. This one is parallel to this one is what we have to prove now. So see this figure here. AB, so what have we taken? AB parallel to CD, AB parallel to CD, cut by transversal T at E and F respectively. That's how you describe the figure. All right. AB parallel to CD, cut by transversal T at E and F respectively. Now AEF and EFD. Where is AEF? See, this is AEF. AEF and EFD and EFD are a pair of alternate interior angles. Correct. Okay. EG is the bisector of AEF. EG is the bisector of AEF. Correct. FH is the bisector of EFD. FH is the bisector of EFD. Correct. Now we have to prove that EG is parallel to FH. EG, this is EG, is parallel to FH. That's what we have to prove. We'll have to prove that this EG, this bisector EG, is parallel to this bisector FH. All right. Okay. Now, AB is parallel to CD and transversal T. T is a transversal. So alternate interior angles are equal. See, here we have just mentioned that they are alternate interior angles. Here we are saying they're equal. Here we have just mentioned that they're alternate interior angles. Here we are saying that they're equal because the lines are parallel. So AEF, this AEF is equal to EFD. AEF is equal to EFD. Why? Because they're alternate interior angles. They're alternate interior angles, so they're equal. So half. Now, when two things are equal, their halves are also equal. If A is equal to B, then A by 2 will be equal to B by 2. Halves of equal are also equal. Halves of equals are also equal. So if A is equal to B, then A by 2 will be equal to B by 2. Similarly, because these two angles are equal, their halves also will be equal. Half of AEF will be equal to half of EFT. Now we know that the angle is this angle is bisected, and this angle is also bisected. Bisected meaning it's divided into two equal angles. Like how you bisect a line segment. Supposing you have a line segment. You have a line segment AB equal to 6 centimeters. Okay. If you bisect this line segment, that means you cut the line segment into two equal halves. That means exactly the midpoint, you'll take a point C. So AC will be 3 centimeters, BC will be 3 centimeters. So C bisects AB. The point C bisects AB. C cuts AB into two equal halves. So you can bisect a line segment. You can also bisect an angle. An angle can be bisected, that is cut into two equal halves. An angle can also be bisected, that means divided into two equal halves. Now we know that this is the bisector. EG is the bisector of this angle. So this portion is equal to this portion. If it's bisected, suppose the angle measures 70 degrees. Each half will be 35 degrees because it's bisected. Okay, supposing this is 70, it'll become 35 here and 35 here. Alternate angles are equal, no? So this is also 70. And if it's bisected, it'll be 35 here and 35 here. So half of AEF is equal to half of EFD. See, you can take half only when the line segment or the angle is bisected. When can you use this, this property? That is when two things are equal, their halves are also equal. When can you use that? Only when the angle is bisected or the line segment is bisected. Simply we cannot do this. When the angle is not bisected or a line segment is not bisected, then there is no meaning taking half of AEF is equal to half of EFD. Only when the line segment or the angle is bisected, you can take their halves. These two things are equal. But because they are bisected, their halves are also equal. All right. Okay. So now here the angles are bisected. So half of AEF is equal to half of EFT. Now what is half of AEF? Which are the two halves? All of you listen to me. The two halves of AEF. AEF is this full angle. See, AEF is this full angle. The two halves of this angle are this one and this one. That is AEG and FEG. FEG. See here, this is the angle AEF. This is the angle AEF. AEF. Now, these are the halves. This one and this one are the halves of that full angle. So how do you call this angle? AEG. Or you can say GEA. GEA is one half. And the other half is, you can say FEG or GEF. You know, you can name an angle in two different ways. You just have to put the vertex in the middle. So this angle can be called FEG or GEF. Both are the same. So this is one half, this is the other half. So for half of AEF, you should write half of that angle. What is half of that angle? This one, GEF, GEF. Half of AEF is GF. And what is half of EFD? EFD. Which is EFD? EFD is this angle. This is EFD. Its halves are this one and this one. So half of EFD is equal to EFH, or you can say HFE. HFE or EFH. The other half is DFH. DFH or HFD. But we are taking these halves. We are taking these halves. Half of this angle, we are taking this. Half of this angle, we are taking this. That is what you see here. EFH. 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 This angle. So what have we written? What have we written? This angle is equal to this angle because alternate interior angles are equal. Half of this angle is equal to half of this angle. You can use this property because the angles are bisected. So now what is half of this angle? This one. What is half of this angle? This one. So you get GEF is equal to EFH. This angle. Okay, you get this angle is equal to this angle. Okay, so this you get GEF is equal to EFH. But what kind of angles they are? See here, some line, transversal, some line. But these two angles are alternate interior angles made by the transversal EF with the lines GE and FH and are equal. And the alternate angles are equal. They're equal. So the lines EG and FH are parallel to each other. So you must not write this. If you understand, you can write this very easily. But I'll tell you again. But see, we are talking about these two angles. But angle, GEF and EFH, these two angles, this angle and this angle. But these two angles are are two interior angles, okay, or are a pair of interior angles made by the transversal EF, this angle and this angle are a pair of alternate interior angles made by the transversal EF with the lines GE and FH. And the alternate interior angles are equal. See here, we got that they're equal. The alternate interior angles are equal. That means the two lines GE and FH are parallel to each other. So GE is parallel to FH. Isn't it very simple, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now we'll do it. We'll try to do it like this. We'll take another figure. Okay. Yeah. Now tell me the proof. We'll have to, it's the same conditions. What is given? What is given? PQ is parallel to what, children? PQ is parallel to
RS, ma'am.
RS. RS. PQ is parallel to RS. PQ is parallel to RS. And which is the transversal?
T, ma'am.
T is the transversal. T is the same question we are trying to do in a different way, children. Okay, T is the transversal. And then which are the pair of alternate interior angles we have taken here?
QAB and ABS.
Yeah, angle QAB and
BR, ma'am.
ABR and angle ABR form a pair of alternate interior angles. Then what else should we write? Who is AQ and BD? Who are AQ and BD? Who's AQ? Oh, not AQ. Sorry, children. AC. Sorry, children. Who's AC?
Bisector.
Bisector.
AC is the bisector. AC is the bisector of
QAB, ma'am.
angle QAB. Very good, very good. And BD is the bisector of? BD is the BD is the bisector of angle
ABR, ma'am.
ABR. Very good, very good. So this is what is given to us. Okay, this is what is given to us. Now we have to prove what? To prove that. Yeah, tell me to prove that.
AC is parallel to BD, ma'am.
To prove that AC is parallel to BD. Very good. Now how will the proof go? PQ is parallel to RS given. and T is a transversal. So angle, whatever we have taken here, QAB, angle QAB is equal to angle ABR because they form a pair of alternate interior angles. QAB is equal to ABR. Alternate interior angles are equal. Whichever pair you have taken, take the same thing now and say that they are equal because their alternate interior angles are equal. Now, half of QAB will be equal to half of ABR. Yes or no?
Yes, ma'am.
Yeah. Now, with what is half of? Tell me the two halves of QAB. The two halves of QAB.
QAC and AB, ma'am.
CAB, ma'am.
Angle QAC and
CAB.
Angle CAB, ma'am.
angle CAB. Perfect. CAB. Yeah. And which are the two halves of the other angle ABR? ABR.
Angle ABD and angle DBR, ma'am.
Angle AB.
ABD and DBR, ma'am.
DBR, very good, DBR. Okay. Now we have to take these angles here because we can see a line here. This is the line. We have to prove that this line is parallel to this line. And if you take this as the transversal, these angles will be alternate interior angles. So you'll have to take this angle and this angle. You should not take this and this. You should not take that. You must take this and this because that they are the angles in the Z. They are the angles in the Z. You have to prove that this line is parallel to this line. So take this angle and this angle. So what is half of QAB? QAB, what is half of that? Take this one. CAB. CAB, angle CAB, okay, is equal to half of ABR. Take this one. Take this one. That is ABD. ABD, this one. ABD, angle ABD. So we get a result which says angle CAB, this angle is equal to this angle. But these two angles form a pair of alternate interior angles made by the transversal AB with the lines AC and BD and are equal. Angle CAB and angle ABD, these two angles form a pair of alternate interior angles made by the transversal AB with the lines AC and BD, and the alternate interior angles are equal. Therefore, AC is parallel to BD. So the bisectors are parallel to each other. AC is parallel to BD. So in given, you should write the two parallel lines, the transversal, the pair of alternate interior angles which you are considering, and you should also mention the bisectors of that pair of alternate interior angles. All this is given. We should prove that the bisectors are parallel to each other. This is how the proof goes. Just 3 steps for the proof. I hope it's clear, children.
Yes, ma'am.
Yes, ma'am.
Lovely. Let's go to the next one. If the bisectors of a pair of if the bisectors of a pair of corresponding angles formed by a transversal with two given lines are parallel. Here the bisectors are parallel. Here the bisectors are parallel. You should prove that the lines are parallel to each other. I'll read it again. If the bisectors of a pair of corresponding angles formed by a transversal with two given lines are parallel. See here, I'll read it like this. I'm sorry to keep breaking. See here, if the bisectors of a pair of corresponding angles are parallel, this is what it is. If the bisectors of a pair of corresponding angles are parallel, this is that information about the corresponding angles. The corresponding angles are formed by a transversal with two given lines. How are the corresponding angles formed? Are they formed by a transversal with two parallel lines, or are they formed by a transversal with simply two lines? See, corresponding angles, alternate angles, co-interior angles, all these angles can be formed when a transversal intersects two lines or two parallel lines. Corresponding alternate co-interior angles can be formed when a transversal intersects two lines or two parallel lines. So you should mention how these corresponding angles are formed. So how are these corresponding angles formed? They are formed by transversal with two given lines. The lines are not parallel. The corresponding angles are formed by a transversal with two given lines. So the lines are not parallel. You must prove that those two lines are parallel to each other. Then which are those which are parallel to each other? The bisectors are parallel. The bisectors are parallel. So now let's read the statement completely. If the bisectors of a pair of corresponding angles formed by a transversal, the corresponding angles are formed by a transversal with two given lines are parallel, the bisectors are parallel, the bisectors are parallel, then prove that the given lines are parallel. Prove that the given lines are parallel. So a transversal PQ, can you see here? A transversal PQ cuts two lines AB and CD, not parallel lines, cuts two lines A, B, and CD. Okay, at E and F respectively, okay. Angle PEB and EFD, PEB, see, okay. So you have four pairs of corresponding angles. You can take any one pair. Okay, of the four, you can take any one pair of corresponding angles. So here we have considered this and this. Now, PEB, this one, PEB, this is one angle, and EFD, okay, EFD are a pair of corresponding angles, Then what? EG is the bisector of PEB, FH is the bisector of EFD. That is angle PEB and angle EFD. Also, EG is parallel to FH. The bisectors are parallel. EG is parallel to FH. To prove that the given lines AB and CD are parallel to each other. So we understand the information given, what is given and what is to be proved.
Yes, ma'am.
Yes, ma'am.
All right. So here we are given okay, a transversal intersects two lines, and we need to prove that those two lines are parallel to each other. What else is given? We have to take a pair of corresponding angles and the bisectors of the corresponding angles. It is given that the bisectors are parallel to each other. With this information, we should prove that the original two lines are parallel to each other. All right. So here, take up the parallel lines. See, how do you start? Take up the parallel lines in the transversal. So which are the parallel lines? EG is parallel to FH. EG is parallel to FH. And EF is a transversal. EF is a transversal. See here, parallel line, transversal, parallel line. Parallel, this is parallel lines and this is the transversal. So see here, parallel line, because the bisectors are parallel. Parallel line, transversal, parallel line. All right. EG is parallel to FH, EG is parallel to FH, and EF is a transversal. EF is a transversal. Angle PEG is equal to EFH, which is PEG, this one. This is PEG. PEG is equal to EFH, EFH, this one. So produce the transversal, children. Produce a transversal. Now here, instead of the transversal EF, you can also write PG, both PQ, both are the same. EF, PQ, all the same. So we are talking about these two lines, children, and this transversal. Just produce the lines. See, just produce the lines. See here, produce them. Now you can make out. See here, transversal parallel line above. The same transversal parallel line above. These two are corresponding angles. Yes or no? PEG, EFH. Are they corresponding angles? I'm talking about this part.
Yes, ma'am.
Yes, ma'am.
Okay, see, I'm extending the parallel lines, and this is the transversal. You can already see the transversal. This is the transversal. Now, transversal parallel line. This is one angle. The same transversal, the other parallel line. I told you the angles here, the angles are always formed between the transversal and the parallel line, the arms of the angle, one arm will be a part of the transversal. The other arm will be a part of the parallel line. We know that an angle has two arms. So here it's very easy to identify the, the different angles formed because one arm will be the transversal, the other arm will be the parallel line. So you can see here, transversal, parallel line. This is one angle, same transversal, other line. This is the other angle. So PEG is equal to EFH. Why? Corresponding angles are equal. Why they equal? Because the lines are parallel. Because the bisectors are parallel. So PEG is equal to EFH, corresponding angles are equal. Now double it. Okay. Double. Twice. Doubles of equals are also equal. Doubles of equals are also equal. So twice PEG is equal to twice EFH. So 2 times PEG. We know that these two portions are equal. And we know that these two portions are equal because bisected. No, the angles are bisected. Okay, this is a corresponding angle. These two are corresponding angles, and these are the bisectors. So already these two angles are equal. Now, when you find twice of these angles, what do you get? Twice of PEG. When you double PEG, it is this full angle. And when you double EFH, if you double this angle, it will be this angle, this full angle. Because these two angles are equal. This portion is equal to this portion. So if you double this one, it is this full angle. If you double this one, it is this full angle. So on doubling it, you get angle PEB is equal to angle EFD So I've given the reason here because GEB, this one is half of PEB. It's okay if you don't try this reason is also it's fine. This itself is clear because we have mentioned that they are the bisectors and all that. Maybe you can just ignore this. You don't have to write this also. We have mentioned that they are the bisectors here. See here, bisectors. So it's understood. You don't even have to give this reason. So we get PEB, this angle PEB is equal to EFD. But they are already corresponding angles. Now we prove that they are equal. PEB is equal to EFD. But these are corresponding angles made by the transversal PQ, with the lines AB and CD. See here, AB, CD, and this is a transversal. See this angle from this transversal to this line. This is the transversal. This is the other line. So there's the angle here, and same transversal, the other line. The angle is here. So that means these two lines are parallel to each other. So, but these are corresponding angles made by the transversal PQ with the lines AB and CD, and the corresponding angles are equal because see here, they're equal. So AB is parallel to CD. Is it okay, children?
Yes, ma'am.
Yes, ma'am. Yes.
Yeah, children. Yeah, I think only these two had asked you to complete. Let's continue. This is actually a part of, a different chapter, but sometimes it is asked. This question is actually not a part of lines and angles, but sometimes, they do ask you. It's actually a part of quadrilaterals, but sometimes they do ask you on lines and angles. So I thought I'll also do this. Now see this one, two parallel lines, L and M. Two parallel, important question, children. I've seen this in many schools. When quadrilaterals is not a part of the portion, this question I've seen in the paper sometimes. So sometimes they treat it as a part of lines and angles. Actually, you can find this one as an example question in NCERT in the chapter quadrilaterals. This is an example question in your NCERT maths textbook in the chapter quadrilaterals. Two parallel lines L and M. Two parallel lines L and M are intersected by a transversal P. Show that the quadrilateral formed by the bisectors of the interior angles is a rectangle. Show that the quadrilateral formed by the bisectors of the interior angles is a rectangle. Let's understand the figure. See here. These are the two lines intersected by a transversal. Now, which are the interior angles? How many interior angles are there? 4 interior angles. They're not saying alternate interior angles, simply interior angles. So there are 4 interior angles. 1, 2, 3, and 4 interior angles. Now you have to take the bisectors of these 4 interior angles. So this is one angle. This will be the bisector of this interior angle. This will be the bisector of the other second interior angle. This will be the bisector of the third interior angle. And this will be the bisector of the fourth interior angle. All right. Now the bisectors of the interior angles, can you see? They enclose a rectangle. See, I'll just show you the rectangle. See it? This one. The bisectors of the interior angles, they enclose a rectangle. I'm sorry, they enclose a quadrilateral. Sorry. They enclose a quadrilateral. Can you see the quadrilateral, children?
Yes, ma'am.
Now we have, very good. Now we have to prove that this quadrilateral is a rectangle. We can't say, yeah, see, it looks like a rectangle only, so it's a rectangle. No, you cannot say that. You'll have to prove it's a rectangle. We'll have to prove it is a rectangle. So what is the question, or what's the information given, or what is the statement? We have two parallel lines intersected by a transversal. So in this case, 4 interior angles are formed, 4 exterior angles are formed. Now leave the 4 exterior angles. Consider all the 4 interior angles. Now take the bisectors, angular bisectors. Take the bisectors of these 4 interior angles. Now you will see that the bisectors of these 4 interior angles, they enclose a quadrilateral. They enclose meaning they contain a quadrilateral. You must prove that this quadrilateral is a rectangle. Now, to prove that a quadrilateral is a rectangle, you must first prove that it's a parallelogram. I'll tell you the definition. We'll be seeing many definitions of special quadrilaterals in the chapter quadrilaterals. In the chapter quadrilaterals, we'll be understanding the definitions. That is, how do you define a trapezium? How do you define a kite? What is a kite? What is a trapezium? What is an isosceles trapezium? What is a parallelogram? What is a rhombus? What is a rectangle? What is a square? So we'll see all this in the chapter quadrilaterals. Now I'll just tell you what you need to prove this one. What is a rectangle? A rectangle is a parallelogram in which one angle is a right angle. You can make a note of that. A rectangle is a parallelogram. A rectangle is a parallelogram in which one angle is a right angle. Please make a note of this. This is the definition of a rectangle. So we have to first prove that this quadrilateral is a parallelogram. And in the parallelogram, one corner is a right angle. So it is a rectangle. This is how the proof goes. The definition will tell you how to prove. Yeah, please write down this, children.
Ma'am, this is example 5, right?
Yeah, right. Yes, example 5.
Okay, ma'am.
Yeah.
Completed, ma'am.
Yeah.
Completed, ma'am.
Yeah.
Completed, ma'am.
All right. Yeah. So I'll just tell you how the proof goes. I want you to read and understand it better. I'll just tell you how the proof goes. Yeah. So the first step, as per the definition, the first step is to prove that the quadrilateral is a parallelogram. Once you prove it's a parallelogram, then you will have to prove that one angle is a right angle. So if you prove that it's a parallelogram, that is, if you prove that this quadrilateral is a parallelogram and one of its angle is a right angle, then you have proved that the quadrilateral is a rectangle. Now let's see how to prove that it's a parallelogram. Now we know that a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Okay, a parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. Now see here. Consider any pair of alternate interior angles. Now first let's take this and this. Let's take these two angles. All right, let's take these two angles. Now we know that AB is the bisector of this angle. So this portion, that is this portion, is equal to this portion. And we also know that CD is the bisector of this angle. So this one is equal to this one. This angle is equal to this angle. Now this angle, that is PAC, angle PAC is equal to angle ACR. What's the reason? PAC is equal to ACR. What is the reason?
Alternate interior angles, ma'am.
Yeah, alternate interior angles are equal. Now half of PAC will be equal to half of ACR. Now what is half of PAC? Tell me which is the angle which is half of PAC.
Angle PAB and angle BAC.
Yeah, now tell me which one to consider.
BAC, ma'am.
BAQ. So half of PAC is angle BAQ. BAQ. See this one, this angle, this one. BAQ, this angle, this
Ma'am,
angle.
it's C, ma'am. Ma'am, it's C or Q, ma'am.
Oh, BAC. Sorry. Even I go wrong. Yeah, BAC. Thank you. Sorry. Not BAQ, BAC. BAC. See your children, sorry. BAC. This is C. This is Q. I said BAQ. I was wrong. It's BAC. BAC. This one. Okay. Now, what is half of ACR? What is half of ACR? What is half of ACR?
ACD and DCR.
Okay. ACD and DCR. So we have to take which one?
ACD.
ACD, ma'am.
ACD. ACD. So now see, you get a new result. You get a new result. What is your new result? Your new result is ABAC. This is BAC is equal to ACD, is equal to ACD. But angle BAC and ACD form a pair of alternate interior angles made by the transversal AC with the lines AB and CD. And they are equal, the alternate angles are equal. Therefore, AB is parallel to CD. So we have proved that in this quadrilateral, one pair of opposite sides is parallel. We have proved that this one is parallel to this one. Now we have to proceed to prove that this side is parallel to this side in the same way. In the same way. In the same way. See, now you will have to prove that this side is parallel to this side. How? So the same thing. What is that same thing? this angle is equal to this angle because alternate interior angles are equal because the lines are parallel. Half of this angle, so that is which are the alternate interior angles? Angle SAC. I don't want to make a mistake. Am I right? SAC, correct? Is equal to what, children? Is equal to angle SAC is equal to yes, SAC is equal to
ACQ, ma'am.
ACQ, correct? ACQ, ACQ. Now half of SAC, half of SAC is equal to half of SAC is equal to half of ACQ.
Q.
Now tell me what is half of SAC?
DAC, ma'am.
DAC, yes. The two halves are this one and this one. These are the two halves. This is the angle. This is one half. This is the other half. We have to take this half. DAC, DAC, angle DAC is equal to what is half of ACQ? This is the angle ACQ. These are the two halves. These are the two halves. This is the angle.
CB, ma'am.
ACB. ACB. We have to take this one. DAC and ACB. Now see, we have a new result. DAC, DAC, this angle is equal to ACB, ACB, this angle. But these two angles form a pair of alternate interior angles made by the transversal AC with the lines DA and CB. With the lines DA and CB. And the alternate interior angles are equal. This angle is equal to this angle. See, we got that. They're equal, but they form a pair of alternate interior angles made by the transversal AC with the lines AD and CB or BC. And the angles are equal. Therefore, AD is parallel to BC. Now we have proved that in the quadrilateral ABCD, both the pairs of opposite sides are parallel. In ABCD, both the pairs of opposite sides are parallel. Therefore, ABCD is a parallelogram. Both the pairs of opposite sides we proved are parallel. So ABCD is a parallelogram. Next, we have to go ahead to prove that one corner of this parallelogram is a right angle. So you should prove either this is 90 or this angle is 90 or this is 90 or this is 90. See, in a rectangle, every angle is 90 degrees, but you don't have to prove all are 90. Any one if you prove is 90, then all the others also will be 90. So this one we'll learn later. But for now, understand, I'm not trying to say if you prove it is enough to prove one angle is 90. But in a rectangle, all the angles are 90 degrees. That is a fact. But you don't have to prove everything is 90. Just prove one angle is 90. That's the definition of a rectangle. So I don't know which one I've proved is 90. So let me just see that here. BAD I've proved. Okay, BAD. This one I've proved is 90. Okay. I proved that BAD is 90. So now we have proved that it is a parallelogram. Now we are going ahead to prove that it's a rectangle by proving either this is 90 or this one is 90 or this one is 90 or this one is 90. Anything you can do. You can do any one of these four. In my working, I have proved that BAD, this one is 90. So let me explain that. Let me explain that. Okay. So now to prove that BAD is 90, this one is 90 degrees, what you have to do is, now, what do you say about these two angles, children? What do you say about these two angles? What do you say about this angle and this angle? What do you say about those two angles? Let me write. Angle, yeah, linear pair. I'm talking about angles PAC and angle SAC. I'm scared. PAC, correct. SAC, yes, children. I'm talking about these two angles. How can you connect them?
Linear pair angle, ma'am.
Linear pair. So their sum is equal to 180. Okay. Now half of, now divide this one by 2 throughout. Divide by 2 throughout. So PAC by 2 plus SAC by 2 is equal to 180 by 2. Now what is PAC by 2? This is PAC. This is PAC. Half of PAC is this one. This one is SAC, this one. Half of SAC is this one because the angles are bisected. The angles are all bisected. So we'll write this and this. Okay, so PAC by 2 is angle BAC. BAC plus SAC by 2. Half of SAC. Half of SAC. I'm going to write this one. DAC. I'm going to write DAC. Angle DAC. DAC is equal to 180 by 2, which is 90 degrees. Now, what is BAC plus DAC? Tell me, what is BAC, this angle, plus DAC? What is this angle plus this angle?
BAD, ma'am.
See here, we are talking about this angle BAC and this angle DAC, this one DAC. So these two put together make the angle BAD, BAD, this one, BAD. So when you add these two, you get BAD, angle BAD. So angle BAD is equal to 90 degrees. So we have proved that ABCD is a parallel. It was only a quadrilateral. We proved it's a parallelogram. How? By proving that both the pairs of opposite sides are parallel. And then we have now proved that one angle of this parallelogram is a right angle. Therefore, ABCD is a rectangle. This is how the proof goes. All right. Now, I want you to help yourself. Read, children. Maybe you have to read everything first and then write. Or some of us will keep writing and understanding what you write. So I'll leave it to you. Any doubts you have, please ask me. I'll just get back in some time, children. Please write, all of you, and mark your doubts, if any. The figures here. Now, don't think you should draw the figure at the end of the answer. You should draw the figure first. I've just placed it here. To the right side, you have to draw the figure. To the right side, you can draw the figure, or just below. You write the question, and below that, you can draw the figure and then continue. Then write given and all that. Draw the figure first, then write given and all that. Not that the figure should be in the end. Don't write everything and then draw the figure like what I have done. Put your figure here. Figure here. Yes, children, please start. Just come back in 5 minutes.
Completed, ma'am.
All right. What about the others?
Completed, ma'am.
All right.
Doing, ma'am.
Very good. Yes, children. So I think you would have found exactly what I explained. Correct?
Yes, ma'am.
Yes, ma'am.
Yes.
Yeah. So this is one part. This is one second. Yeah, this is one part where we prove that this angle is equal to this angle, and therefore this line is parallel to this line. And then this is the other part. So this one is the other part where we prove that this angle is equal to this angle, and so this line is parallel to this line. So having proved these two, see, I've called them 1 and 2. AB parallel to CD, I've called it 1, and AD parallel to BC, I've called it 2. So from 1 and 2, from 1 and 2, ABCD is a parallelogram. ABCD is a parallelogram. That I've called, that result I've called it 3. ABCD is a parallelogram. That result I've called it 3. From 1 and 2, we get this result 3. It's a parallelogram. Now we have to prove that one angle is a right angle. So we prove that BAD is a right angle. This is BAD. This one is 90 degrees. So now this is 3 and 4. What does 3 say? ABCD is a parallelogram. What does 4 say? In the parallelogram ABCD, BAD is 90 degrees. In the parallelogram ABCD, BAD is 90 degrees. Therefore, from 3 and 4, ABCD is a rectangle. It's very simple, children. Just that it looks big. But I hope you all understood it very clearly. Any questions, please ask me. Any part you don't understand, please ask me. Okay. All right. All right, children. So this is example 1 in NCERT. What do you say about angles POR and ROQ? What kind of, oh, sorry, ROQ is here. So POR, this angle, and ROQ. What do you say about these two angles?
Linear path.
Linear pair angle, ma'am.
Linear pair, linear pair. Yeah. Linear pair. Very good. I think you can understand this. Please write down, children. You can also work it like this. 5x, let one angle be 5x, the other angle be 7x. So 5x plus 7x is equal to 180. You can also do it like this.
Yes,
Or
ma'am. That's how we
yeah.
did it in our school.
Okay. So here I've this is 5 plus 7 is 12. 5 plus 7 is 12. So 5 parts out of 12 parts. 7 parts out of 12 parts. 5 parts out of 12 parts. 7 parts out of 12 parts into 180 will give you the angles. Anyways, you can do it. See, I'll work it the other way. So okay, if you're all comfortable with that, you can do it like this. Let angle POR be equal to 5x degrees. Let angle ROQ be equal to 7x degrees. So now angle POR plus angle ROQ is equal to 180 because linear pair. So 5x plus 7x is equal to 180. 12x is equal to 180. X is equal to 120, 15. X is 15. Now angle POR will be equal to 5 into 15. 5 into 15, 75 degrees. And ROQ is equal to 7 into 15, 105 degrees. Then you should just write this vertically opposite angles. and the other angles. You can also do this. Please write down. Is it over, children?
1 minute more.
Yes, ma'am.
Okay. Yeah.
Completed, ma'am.
Yeah, very good. All of you?
Yes, ma'am.
Yes, ma'am. Yes.
Okay, class, use the emoji. Raise your hand. Pushmika, Shri, Madhumita, Tanishka, Netra, Sindhu, Sanjay, Arjun, and Srijana. Very good. Yeah. Yeah. Yes, children. So this is over, right?
Yes, ma'am.
Yes, ma'am.
All right, children. Let's see the next one. So in the figure, ray OS stands on the line POQ. So see here in the figure. Okay, so in the figure, ray OS. Oh, it's on this side, is it? Okay. POQ. Ray OS stands on the line POQ. Okay. Ray QR. Oh my God, what happened to me? Ray OR and OT are bisectors of POS and SOQ respectively. Okay, so OR bisects POS. POS, this is POS. It's given that OR bisects POS. OR bisects POS like this. Okay, this is OR. It bisects POS. And OT bisects SOQ. This is SOQ. This is SOQ. And OT bisects SOQ. Now you need to prove that, or you need to find angle ROT given that POS is X, which is POS, this one, this full thing is X. This one is X. This one is X. You need to find ROT. That is this angle. ROT, this one. You need to find this angle, children. ROT. Okay. You need to find this angle, ROT. Okay. Now, what is ROT actually, children? What is ROT? What is it made up of? Tell me. What is ROT made up of? ROS and
SOC.
SOT, correct? ROT,
Yes, ma'am.
ROT has two angles in it. ROS and SOT. If you find ROS, and find SOT, you can add both and find ROT, correct?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. So now what is ROS? Okay, so I'll tell you again. When ROT is made up of this angle and this angle. Let us find this angle. Let us find this angle. Then we'll add both to find ROT. So that is our idea. Now how to find ROS? Okay. ROS. So ROS, angle ROS is equal to half of angle POS because it's a bisector. It's given that OR is a bisector of POS. It is given that OR bisects angle POS. POS. So angle ROS will be half of angle POS. Why? Because it's bisected. So these are the two equal parts. These, see, it's marked also here in the figure. This one is equal to this one. These two angles are equal. So ROS will be half of X. Half of X. Because POS is X. Half of X. Now what about SOT? OT bisects angle SOQ. So angle SOT will be half of angle SOQ. And what is SOQ? SOQ is nothing but 180 minus X. 180 minus X because this full thing, this is 180. I'm sorry, X. The remaining thing will be 180 minus X. See here, which is X. Just a second, children. Somebody's calling me. Just a second. Children, I'll just show you the answer slide. Please write down. I'll just come back. Very sorry about it, children. Please write down the answer. I'll just come back.
Completed, ma'am.
Yeah, children, I'm sure all of you finished writing. So I was talking about this portion, ROT, this full angle ROT is equal to ROS plus SOT, ROS plus SOT. And ROS, this one, ROS is half of, see here, ROS, this one is half of this full angle, half of this full angle POS, half of POS, because it's bisected. And this SOT is half of this full angle. This is the bisector. So SOT is half of SOQ, half of SOQ. And we already know these two angles. What is POS? POS is X. It's given in the question. POS here is X. Is X. So half of POS is half of X. And what about SOQ? We find that by linear pair. We find that earlier by linear pair. SOQ is equal to 180 minus X. So half of SOQ, half of 180 minus X. So how do you work this? How do you work this? Half of X is nothing but X by 2. And this one is nothing but 180 minus X by 2. So 2 is the common denominator. 2 is the common denominator. So you get X plus 180 minus X. X minus X gets cancelled. 180 by 2, 90. So the measure of ROT is 90 degrees. All right, children?
Yes, ma'am.
All right, children. Fine. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children. Thank you, children. Thank you. Thank you, children.